Hi everyone. Today I brought a very good question from the chapter of electrostatics. Okay. The question says A, B and C are three identical metallic plates, each having area capital A. Initially charges Q, 4Q and 2Q were given to the three plates A, B, C respectively. So these are the initial charges given to the three plates. Find final charge distribution. So final charge distribution means we have to find charge on the surfaces, the inner surface and outer surface of all the three plates when B is earth and A and C are connected with a conducting wire. Now to solve that question, we need to know what happens when one of the plate is grounded. Okay, and these are the two important things which happens, and I will give a proof of this, a simpler proof of this at the end once I complete the solution of this question. Okay, so what is the important thing that happens when one of the plate is grounded? Let's read. When there are n parallel plates which are given some charges q1, q2, q3, let's say, and one of them is grounded, any one of them, then first thing, the charge on the outer surfaces of first and the last plate will become 0. So that means if let's say you have n number of plates, okay, which are initially having some charges q1, q2, q3 and qn. Now if any plate is grounded, then it is found that the charge on this side of the first plate and the charge on this side of the last plate, that charge should be 0. Now as I told, why this happens I will explain at the end. The second thing that happens is a charge equal to total charge on the n plates, the total charge given to the n plates will flow to the ground. So when one of the plate is connected to ground, the charge that flows to the ground is equals to total charge given to the plates. So this much charge will flow to the ground. So I'll try to prove this for a simpler case in the end. Okay. Now one more thing you need to know to solve that question is, if you have two large conducting plates or two infinitely large conducting sheets, and if charge here is q, then charge on this side will always be minus q. So if charge here is q, charge here is always minus q. Let us try to understand why it is. So let's assume charge here is q dash. Now I will prove that q dash is q by considering a Gaussian surface, a closed Gaussian surface like this. Okay, so you can think of it as something like this in 3 dimensions. Now this side is here inside the metal, this side, this part is inside this metal, and these surfaces and these surfaces and back surfaces and front surfaces are here. Okay, the top one, the bottom one, the front one, the back one. So it's a closed surface, and remember these are two plates. Okay, now you know that plates produces electric field which is uniform. Let us assume q is greater than q dash, so that electric field is this side. Now if you look carefully, for this surface area vector will be here. So for this surface area vector is here, electric field vector is here. So flux through the surface will be 0. So flux through this surface is 0, flux through this surface is also 0, for same reason area vector will be here. Similarly for this surface, for this side, remember this is a cuboid kind of thing, right? This is a closed surface. So for this surface area vector will be here, electric field vector is here, again flux is 0. For back surface also the flux is 0. Now we are left with this surface and this surface. Now this surface is inside the conductor, and we know inside the conductor electric field is 0. Requirement it is for electrostatic conditions, right? So here electrostatic field inside is 0, here is 0. So flux here is also 0, flux here is also 0. So flux through all the 6 surfaces is 0. That means total flux through the closed surface, this closed surface must be 0. Now from Gauss law, it means charge inside by epsilon naught should be 0. So charge inside the closed surface must be 0. Therefore, Q plus Q dash, which is the charge inside, must be 0. So Q dash must be minus. Right? Now let's come back to the original question. So you can see that these are the 3 plates and the plate B has been grounded, right? And I already told you before that when one of the plate is grounded, the charge here and charge here will become 0. Try to remember that. So charge here and here became 0. So that's nice. Now these two are joined, isn't it? So this system is not isolated because this is connected to this system. So this is not an isolated system. This is not an isolated system. But look carefully. This is isolated system. This one. This is isolated system. A and C together. So this is the boundary of the system. Why this is isolated? Because these two systems together is not connected to any third object, isn't it? We cannot say this is isolated because this is connected to ground. But these two plates together is isolated. So the total charge given to these two, the total charge given to these two plates must remain conserved. So since A plus C together is isolated, their total charge must be conserved. Now what was the total charge of the two plates? Initially Q plus 2Q. Now let us assume here charge is X and here charge is Y. Okay. So as I told you, here and here charge is 0. That is always true, remember, because one of the plate is grounded. So here charge is 0, here charge is 0, and here we don't know the charge and here we don't know the charge. So let me assume charge on this side is X, charge on this side is Y. So what is the total charge after you do all this connection for plate A and C? What is the total charge? Obviously X plus Y. So from here X plus Y will come equal to 3Q. This is equation 1, let us assume. To solve this, we need one more equation between X and Y. From where that equation will come? Now look carefully, plate A and C are connected by conductor. So therefore this whole thing will be at one potential, right? And this is another plate, let us, this is given as B, right? So potential difference between A and B must be same as potential difference between C and B, isn't it? Because VA and VC are same only. Why they are same? Because this is one conductor now, and we know in electrostatic conditions, inside the conductor electric field is 0. So potential everywhere should be same. Now what is potential difference between these two plates? Well, from Gauss law, which I discussed before, I told you if this is X, this side must be what? Minus X, isn't it? And if this is Y, this side must be minus Y. So you can see this is like a capacitor with inner surfaces having charge X and minus X, right? So the potential difference here between these two will be X, which is Q by C. So potential difference between these two plates will be X divided by capacitance of the pair AB. Remember, the potential difference between two plates of a capacitor is given by Q by C, and Q is the charge on the inner surface of the positive plate, right? Why these charges do not come in this formula is because these charges will not create electric field here. That is because this is a conductor, and conductor shields outside charges from inside, meaning these outside charges will create here electric field 0. You can check actually, due to plus y electric field here will be away, due to minus y it will be towards, and those two will cancel because these are infinite sheets, right, large plates, and therefore these electric fields are uniform. So due to this sheet and due to this sheet, electric fields will cancel. So that's why those charges will not come here. Okay, whenever you write potential difference between two plates, only these charges are important because only those charges create electric field in between these two plates. And potential difference at the end of the day, remember, is calculated using electric field, right? Because potential difference is electric field into distance between the plates, isn't it? But here I am using this formula because capacitance formula we all know easily for a parallel plate capacitor. Similarly, what will be potential difference between B and C? It will be Y divided by charge on the positive surface of this pair of plates and capacitance of this system, which is BC. Now, what is capacitance? Epsilon naught A by D. D is the distance between the plates, which is given as D, and capacitance between B and C will be epsilon naught A by 2D, isn't it? This gets cancelled, D gets cancelled, 2 goes up, so X will be equal to 2Y. So then I can substitute that in equation 1, right? So in equation 1, if I substitute, what will I get? X plus y is 3q, x is 2y, so 2y plus y equals to 3q. So y will be equals to q itself. And if y is equals to q, what will be x? 2q, right? Isn't it? So we found x and y. So what would be the answer now? So the question was to find charge distribution on the surfaces of the three plates. So here what is the charge? 0. Here what is the charge? X. X is 2q. Here what is the charge? Minus x. So minus 2q. Here what is the charge? Y, which is minus y, which is y is q, so minus q. And here what is the charge? Plus q. And here obviously the charge is 0. By the way, notice something. If they ask how much charge went to ground, what will you tell? What was the charge on this plate before? These are the initial charges. So what was the charge on this plate initially? 4q. Right? So let me discuss in this part. Initial charge on plate B. Initial charge on plate B is equals to 4q. What is the final charge on plate B after grounding? Minus 3q. Correct? Minus 2q minus 3. Now, if right now I have 10 apples, initially 10 apples, and now I have 4 apples, then how many apples went out from me? 6 apples, initial minus final. So how much charge went to ground? Charge flow to ground, or charge going to ground, will be initial minus final. Right? Final is minus 3q. So that will be 7q. And if you remember, I told you before that whenever one of the plate is connected, total charge on the plates will go to ground, isn't it? So what is the total charge on the plates? Q, 4q, 2q is 7q. And we found 7q goes to ground. Right? And now, if they ask potential difference between A and B, we can do, right? Suppose in the same question, they ask you to find potential difference between A and B. So that will be potential difference between A and B will be charge x divided by C between A and B. X how much we found? 2q, and q and C is epsilon naught A by B. So that would be the potential difference between A and B. What would be potential difference between B and C? That would be equals to y, charge on the inner surface of positive plate, divided by capacitance of B and C. And y we found as q, and C is epsilon naught A by the D, and D is 2D, right? So this will give you 2qD by epsilon naught A. And as you guessed, those two should be same. Now let me try to prove to you the first general statement which I told, that if there are n plates and if one of the plate is grounded, the charges on the outer surfaces of first plate and last plate will be 0. Now to show that for n plates is not so simple, so I'll try to show it for 2 plates, okay? So let me consider these 2 plates, okay? And I have given initially charges q1, q2. These are 2 large plates, okay? Now let me try to tell you that if no plate is grounded, then what is the distribution of charge on the surfaces of the plates? So here on this side, let me assume the charge on this side is x. Then I told you charge on this side will be what? Minus x before, right? Also this is isolated. It's not connected to anything. So total charge should be same as whatever charge I gave before, right? Whatever charge initially it has, same it should have later also if the plate is isolated. That is called conservation of charge. So since initial charge is q1, final charge on the plate also should be q1. So if this side is x, this side should be q1 minus x. So that when you add these two, you will get initial charge. Similarly, this one should be how much? q2 plus x. Okay, then when you add these two, you will get the initial charge given to the second plate. Now let me take one point inside the metal, and you know that under static conditions, electrostatic field at that point must be 0 due to whatever charges are there. So since we know electric field here is 0, let us now try to find what is the electric field here due to different charges. So electric field at P due to this charge, let me call this side as 1, this side as 2, this side as 3, this side as 4. So let me calculate electric field here due to the 4 surfaces. So due to this sheet of charge, positive I have assumed, right? q1 minus x means here plus sign is there, isn't it? No sign is there means plus sign is there. So due to this positive sheet, electric field here will be away from the positive plate. So if this is the point P, due to first sheet, electric field will be away. Then due to second sheet, which has charge plus x, it will be away. Now due to this minus sheet, so if I zoom this carefully for you and show, this charge is minus and this point is on the right side of this plate. So due to minus, electric field will be towards the minus. So electric field at P will be this side due to the third sheet. And due to the fourth sheet, remember fourth sheet is positive, q2 plus x, and point P is here. So due to plus sheet, electric field will be away from the plus sheet, isn't it? Electric field due to the fourth sheet will be away, left side. Okay. So since I know the directions of electric field, the resultant electric field will be what? E1 magnitude plus E2 magnitude minus E3 magnitude minus E4 magnitude. Then if you take these two that side, you will get E1 plus E2 should balance E3 plus E4 in magnitude. Correct? Now, electric field here due to this sheet. Now, what is the formula for electric field due to infinite sheet of charge? Sigma by 2 epsilon naught. Here I am assuming charge is this. So, let us write this formula in terms of charge. So, charge by area. Area of each plate we are assuming same. So, what is electric field due to this sheet? Sigma is charge by area. Charge is Q1 minus X by area divided by 2 epsilon naught plus electric field due to second sheet. Remember, this is the second sheet. Okay. Charge is X. So, X by A is sigma divided by 2 epsilon naught. Now, due to third sheet, charge is minus X. So, this is magnitude. So, X by 2A epsilon naught. Due to this sheet will be what? Q2 plus X is the charge by area is sigma divided by 2 epsilon naught. These two will cancel, right? You bring it this side, minus plus will cancel. So what is left? These two are left. There also these two will cancel. So Q1 minus X will be equal to Q2 plus X. So Q1 minus Q2 will be 2X. So what will be X? Q1 minus Q2 by 2. Okay. So what are the final distribution of charges on the surfaces of these plates? Here what charge we found? Q1 minus Q2 by 2. Then automatically here what will be charge? Minus Q1 minus Q2 divided by 2. Correct? What will be charge here? Well, charge here is Q1 minus X. X, how much we found? Q1 minus Q2 by 2. So if you take LCM 2 Q1 minus Q1 minus plus Q2. So you will get Q1 plus Q2 divided by 2. Right? So charge here is, if you can remember, Q1 plus Q2 divided by 2. Charge here will be what? Q2 plus X. So Q2 plus X means Q2 plus X is Q1 minus Q2 by 2. So if you take 2Q2 plus Q1 minus Q2, here also you will get Q1 plus Q2 divided by 2. So Q1 plus Q2 divided by 2. So we learned this is the distribution of the charge on the surfaces of the two plates A and B. Now let's say one of the plate is grounded. Let's say B is grounded. Now, the moment you connect this plate to ground, the potential of this plate will be 0 volt, same as ground. And infinity, somewhere very far, there also potentially 0 volt. So, between this plate and infinity, you can see there is no potential difference. Both are 0, 0. So, electric field outside must be 0 here. Now, electric field here 0 means the outside here there should be no charges. So that means the charge here must become 0 compulsory. Otherwise these charges will create electric field here. Isn't it? Now in this case you can see this is plus, this is minus. So electric field here will be this side. These two will not create electric field here because electric field of this will be away from this. Electric field of this will be away from this. So those two will cancel. But because this side is plus and this side is minus, there will be electric field here. What about outside? Is there electric field? Yes. Due to this one, it will be away. Due to this one also, it will be away. Similarly here, due to this charge, it will be away. Due to this charge, it will be away. Here there will be no electric field due to this inner surfaces. Why? Because this inner surface here outside the plate, this inner surface will create away electric field and this negative charge inner surface will create towards electric field. So those two will cancel. So right now there is electric field in between the plates, outside the plates also. But once you connect this to ground, outside there cannot be electric field. So there cannot be charges here and here. So these two charges must become 0. I don't mind if charge is here. Here charge can be there because we know this will be plus, this will be minus. So electric field here due to those two will cancel, isn't it? Due to plus away, due to minus towards. And that is called electrostatic shielding, isn't it? So when you have an infinite plate here, the charges this side will not create net electric field that side. So the net electric field outside due to charges this side will be 0. And that is only possible if charge here and here is 0. So that is how we should understand that if one plate is grounded, charge on the outer surfaces of the first plate and last plate must be 0. Now remember, this is isolated. So charge Q1 was given. So this charge, total charge on this should remain Q1 because this is isolated. So this must become Q1 here because this side there is no charge. So whatever charge was given should come here. That means this should become minus Q1. Isn't it? This inner one. So how much charge came to ground, or how much charge went to ground if they ask? Charge flown to ground if they ask. How will you do? Initial charge on B minus final charge on B. Isn't it? So what is the initial charge on B? Initially charge on B was Q2. What is the final charge on B? This side is 0, this side is minus Q1. So this will be Q1 plus Q2. So how much charge flows to ground? The total charge that was given to the plates. That is what I was trying to prove, isn't it?